Hello everyone, my name is Dr. Roshan Kumar. I am Assistant Professor in the Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. So today I will talk about what is breakdown in the diode and why breakdown occur in the diode. Basically, breakdown occur in the diode when the reverse bias voltage become very larger. At high reverse voltage, the electric field across the depletion region becomes extremely strong. This strong electric field is the main reason breakdown occurs. Let us understand how happen in breakdowns. In In the reverse bias, depletion region width increases. Majority carrier move away from the junction. Only a small minority carrier current flow, but we we keep increase the reverse voltage. The electric field inside the depletion region increases and carrier gain very high kinetic energy when energy becomes large and enough. Breakdown happen. There are two breakdown mechanism, that is uh, Zener breakdown, that is low voltage breakdown, and another is avalanche breakdowns. So Zener breakdown happen when reverse voltage increase, electric fields become extremely strong. The strong field pull the electron the directly from the valence band to conduction band. This process is called quantum mechanism tunneling. So sudden increase in reverse current, so Zener breakdown occurred due to a very strong electric field in a thin depletion region. So let us I will explain you so one by one for Zener breakdown and avalanche breakdown. So there are mechanism. Doping levels is Zener breakdown is heavily doped, but in case of avalanche breakdown is lightly doped. So depletion width in Zener breakdown is narrow and depletion width in avalanche breakdown is wide. So and breakdown voltage in Zener case will less than 5 volts, but in avalanche breakdown voltage is greater than 6 volt. In case of temperature coefficient, the Zener breakdown is negative and avalanche breakdown is positive. So there are two types of breakdown, Zener and avalanches. Let us understand each one clearly. So Zener breakdown occur when heavily doped p-n junction diode. Because of heavy doping, the depletion region becomes very thin, very small. Reverse voltage produce a very strong electric fields generated. When the reverse voltage increases, the electric field become extremely strong. This strong field pull electron directly from valence band to conduction band. This process is called quantum tunneling. As a result, sudden large reverse current flow breakdown occur at low voltage. So Zener breakdown usually occur at voltage less than about 5 to 6 volt. This type of breakdown is controlled and is used in Zener diode as a voltage regulators. So Zener breakdown is a special type of breakdown that can occur in diode when its reverse bias and reverse voltage reach a low critical voltage values. Let, let us condition for Zener breakdown. Zener breakdown occur in the heavily doped PN junction diode and thin depletion region and low reverse breakdown voltage usually below 5 to 6 volt because of the diode is heavily doped. The depletion region become very thin. This type of depletion region is the key region of a Zener breakdowns. So in the reverse bias, voltage is applied. Depletion region bends slightly. Electric field developed across the junction. As a voltage increases, electric field becomes very strong. Since the depletion region is already thin, even a small increase in the voltage produces a very instant electric field. So what is the actual mechanism and why it's happen when electric field become extremely strong? It's extract a heavy, very large force on electrons. So electrons in the valence band gain enough energy. They directly jump into the conduction band. This process is uh, called quantum tunneling. So no collision required. Electron tunneling through the thin energy barrier. As a result, a large number of electrons suddenly becomes free. Reverse current increases sharply when breakdowns occur. So according to energy band gap, in a heavily dopings, the energy bands of P and N regions comes very close. The depletion width is very small. A strong electric field reduce the barrier's thickness. Electron tunneling from valence band of P region to conduction band N regions. This is this is cause sudden current flow. So what are the important characteristics uh, occur at low voltage? Very sharp breakdowns, has negative temperature coefficient. Current must be limited using a resistors. If current is controlled, the diode will not be damaged in the Zener breakdown mechanism. So what are the application in Zener breakdowns? That the Zener diode is as a voltage regulator, voltage reference circuit, over voltage protection circuit. Zener diode are especially designed to operate safely in breakdown region. Next is avalanches breakdowns. So avalanches breakdown occur when diode is reverse bias and reverse voltage become very high, causing a sudden large increase in reverse current. Let us understand how and why this happens. So that condition for breakdowns, avalanches breakdown occur in lightly doped PN junction diode, wide depletion region, high reverse breakdown voltage usually greater than 6 voltage in Zener diode, voltage below the 5 volt but 5 to 6 volt. In a avalanche breakdown, voltage level above the 6 volt. Because of the diode is lightly doped, the depletion region is wide, therefore a higher reverse voltage is required to create a strong electric field. So next is what happens in reverse bias. When reverse voltage increases, the electric field across the depletion region increases. Minority charge carrier present in the junction start moving this carrier acceleration due to the strong electric field. As a voltage increase further, carrier gain very high kinetic energy. So actual mechanism and impact ionization. What is the actual mechanism for avalanche breakdowns? When high energy carrier moves through the depletion region, the they collide with atom of the crystal lattice. This collision knock out the valence electrons and new free electrons and holes are created, generated, and new free electrons and holes are generated. This newly generated carrier also accelerates and collides with other atoms. This creates a chain reaction. This process is called impact ionization. Because of this multiplication of carrier detected electron and holes, the reverse current suddenly increases. This sudden large current is called avalanche breakdown. So what is called avalanches? Means it is called avalanches because one carrier create many carriers. Means that one electron create many electrons, like that the number of carrier multiply rapidly, just like a snow avalanches growth is quickly as to move the downhill. So important characteristics of avalanches breakdown occurs at high reverse voltage region, happen is lightly doped diode, depletion region is wide, has positive temperature coefficient, current must be limited to prevent the damage of diodes. If current is properly controlled, the diode can operate safely in breakdown region. So application of avalanches diode, surge protection circuit, over voltage protection, and photo detectors. So let us see this picture. This is a IV characteristics of breakdown diodes. This when this characteristics helps to understand the when is breakdown happen and which region breakdown happens. So let us recap the PN junction bias. Biasing, when in a PN junction, positive terminal is connected to N side and negative terminal connected to the P side. That type of biasing is reverse bias. So depletion region wider, only a small reverse saturation current flow that in that device. This small current is almost constant and is due to minority carriers. So what happen in IV graph? If we draw the IV characteristics curve, horizontal axis denoted to voltage, maybe forward, maybe reverse bias, and vertical axis denoted as a current for forward current and reverse current. If reverse bias voltage is taken in the negative direction, there is two important reason: reverse saturation region, breakdown regions. Means before breakdown means reverse saturation region, when reverse voltage is small, current is very small. Before breakdown, current is very small. It remain almost constant. This current is called reverse saturation current. On the graph, it appears as a nearly flat line close to the voltage axis. So breakdown point as a reverse voltage increase further, it is a critical value called breakdown voltage. It's denoted by V naught. At this point, current increase suddenly. The curve become almost vertical. A small increases in voltage cause a larger increases in current. We can see in that AV characteristics. This mark is the beginning of the breakdown region. In breakdown region, reverse current increases sharply. Voltage across the diode remain almost constant. The diode conduct heavily in reverse directional. This is happened due to the Zener breakdown at low voltage, avalanche breakdown at high voltage. So after that, after applying above 5 volts, 5 to 6 volt, then avalanche breakdown happen. We can see in that figure in left side in second numbers line, current line showing the avalanche breakdowns. The curve rises state, steeply down in the negative current direction. So what is the observation in IV characteristics in breakdown mechanism? Breakdown voltage is well defined. After breakdown voltage, change very little, current increase rapidly. Diode must be protected using the series resistance. If current is no limit, the diode may get damaged. So what is the practical significance? The breakdown IV characteristics is very important in Zener voltage regulation, over voltage protection circuit, and voltage reference circuit. Zener diode are especially designed to operate safely in breakdown region. So, so next is application of breakdown, Zener breakdown and avalanche breakdown. So first is Zener breakdown used as a voltage regulator, reference voltage generator, surge protections, and avalanche breakdown, avalanche photodiode, high voltage protection circuit. Next is Capacitance in diode. So first thing, why capacitance occur in diode? So many students think the diodes only conduct the current, but in reality a diode is also behave like a capacitor under certain condition. Let us understand why this happen. So basic idea of capacitance: when two conducting regions are separated by insulating material, that is made by capacitor. So charge can be stored on both sides of the conducting metal plates. A capacitor store energy in the form of electric field. Now let us connect the idea to the PN junction diode. So, structure of PN junction diode, we have a P region and N region. Between them, a depletion region is formed. In the depletion region has no free charge carriers. So it's we have like a insulating layer. Now observe carefully. P regions we have like one conducting plates, and N region we have like another conducting plates. So depletion region we have like a insulating dielectrics. So this is exactly like a capacitor structure. That's why capacitance is occur in diodes. So there are two capacitance occur in the diode. One is junction and depletion layer capacitance. Another is diffusion and storage capacitance. So I will discuss you one by one. Now, so first one is junction capacitance. This type of capacitance mainly occur when the diode is operated in reverse bias. Let us understand it clearly. So why does junction capacitance occur? In a PN junction diode, P region and N region like a two conducting plates. Between them there are a depletion region. Depletion region has no free charge carriers. It's behave like a insulating layer. This structure is similar to the parallel plate capacitors. Conducting plate, that is depletion region, and dielectric conducting plates. Therefore, the diode we have like a capacitor. This capacitors is called junction capacitance and depletion capacitance, or you also call depletion capacitance. What happens when in junction capacitance? When reverse voltage is applied, depletion region with increase charge accumulated on both sides of the junction. The stored charge create an electric field. Since capacitor is the ability to store the charge, the junction show the capacitance. So formation of junction capacitance is denoted by Cj. Cj is nothing but Ef's permittivity and area upon the width. So the capacitance is inversely proportional to the depletion width. A reverse voltage increases, width increases, Cj decreases, so the junction capacitance decreases with the increasing of reverse voltage. So voltage depends of more accurately, Cj is inversely proportional to the voltage and built-in voltage. So V is applied voltage and VVI is built-in voltage. So let us take one example. That question is that a diode has two capacitance, that is 20 picofarad. The voltage across the diode changes at the rate of 5 into 10 raised to power 8 volt a second. Find the capacitive current. So we know that capacitive current is nothing but Cj into dV into change is voltage and change is time. So after putting this value, we got the 0.01 amperes. Next is diffusion capacitance. So diffusion capacitance is mainly occur when the diode is operated in forward bias. So let us understand why happen. So when the diode is forward bias, the barrier potential decreases, the depletion region becomes narrow, a large number of magnetic carriers occur at the junction. For example, electrons move from N region to P region, holes move to the P region and P region to N region. These carriers do not disappear immediately. So they accumulated near the junction as excess magnetic carrier. This is store the charge is the key reason for diffusion capacitance. Why is called the diffusion capacitance? The carrier that cross the junction move due to the diffusion process since the capacitance is defined as a C is dq by dV. So Q is storage charge, V is applied voltage in forward bias. A large amount of charge is stored near the junction. Even a small change in voltage changes then the stored charge significantly. Therefore, diffusion capacitance is a produce. So diffusion capacitance is denoted by CD is inverse directly proportional to the currents, and CD is nothing but uh, it is a ratio of mean lifetime and thermal voltage. So we can see that equation CD is equal to tau I eta Vt, where tau is mean lifetime, I is a current, and Vt is the thermal voltage, eta is diode ideality factors, that is 1 for germanium, 2 for silicons. So that another type of numericals for a another type of numerical with for the diffusion capacitance, a PN junction numericals is PN junction diode, a current of 1 milliampere flow, the carrier lifetime and electron and holes is 1 microsecond. If the value of thermal voltage is 25.85 millivolt and the diode ideality factor is 1.5, then calculate the value of diffusion capacitance. So that the given data, I current is given 1 milliampere, so we can convert to milli to ampere. So multiply into 10 to the power minus 3. Tau is lifetime in microseconds. So 10 to the power minus 6. and Vt is thermal voltage, that is 25.885 millivolt. So convert in volt, that is 25.85 into 10 to the power minus 3. So eta is 1.5. So we can put the all value in this equation. Cd is equal to tau I eta Vt. So we can get 25.8 into 10 to the power 8 farad. So this is all about the uh, breakdowns, what types of breakdown occurs in PN junction. There are two types of breakdown: avalanche breakdown, Zener breakdown. Why capacitors generated in the PN junction? There are two types: diffusion capacitance and junction capacitance. So thank you for watching my video.